This is the Algebra 1 Summer School, Unit 5, Mixed Factoring Practice, Even More Practice. We called it a reteach, relearned. You can use it after you've attempted to take the factoring unit test and maybe not gotten the grade that you needed to pass the unit, or you can use it before that as extra mixed practice. All right, each of the files within this lesson are broken up by factoring type. I'm going to do a couple problems from each kind of factoring. If you have other questions than these, you're going to need to check the key that's posted on Canvas or come into office hours and ask your instructor for help. Before we start, here are some helpful hints for factoring. First, extremely important, always look for a GCF first, right? Look and see what the terms have in common. This will make numbers smaller and make things simpler in order to factor anymore. If you're given two terms, after you look for a GCF, you're going to look for difference of perfect squares, all right? There has to be a minus sign in the middle, two terms, and you have to be able to take the square root of both. If you're given three terms, you're going to use split the middle, all right? It says don't forget to check your answer by distributing, using the distributive property. Let's start with doing GCF, all right? So there's an example up at the very top. I'm going to jump right down to the practice number 1, 2, 13, and 14. When I look for a GCF in number 1, I look for numbers that can go into 2 and 8. That number is 2. So I put a 2 out in front of a set of parentheses, and I divide each term in the polynomial by 2. 2x divided by 2 is 1x. Negative 8 divided by 2 is negative 4. All right, that's your final answer. If you wanted to check if this was right, you would distribute the 2. 2 times x is 2x. 2 times negative 4 is negative 8. That matches my original, so you know you factored correctly. Looking at number 2, I'm trying to find a GCF between 12x squared and 10. It seems that 2 also goes into 12x squared and 10. So 2 is my GCF that I'm going to divide out of each term. 12x squared divided by 2 is 6x squared. 10 divided by 2 is 5. I couldn't pull an x out in the GCF because the 10 does not have an x next to it. So that's your final answer. 2 times 6x squared plus 5. When I look at 13, I have 4ab squared plus 12a squared b. In order to find the GCF for these more complicated looking problems, let's identify the GCF for the numbers first, 4 and 12. The greatest factor that goes into 4 and 12 is 4. Now both of these terms also have an a. The first one has 1a, the second guy has 2 a's. So that means they only have one a in common. When I look at the b's, my first term has 2 b's, the second has 1. So just like the a's, they have one b in common. So my GCF is 4ab. That's what I need to divide everything by. When I divide 4ab squared divided by 4ab, the first term I'm left with is just a b. The 4's and the a's canceled off. The second term, 12 divided by 4 is 3. A squared divided by a is a. And b divided by b cancels off. So this is your final answer, 4ab times b plus 3a. All right, finally, same type of idea. Let's find the GCF between the 2 and the 8. 2 goes into both 2 and 8. For my first term, I have 2 x's. The second has 3 x's. That means they have 2 x's, x squared, in common. For the y's, the first term has 5 y's in common, and the second has 2. So the most they share is a y squared. Now I'm going to divide by 2x squared, y squared, and see what I'm left with. In the first term, the 2's will cancel, the x squares will cancel, and y to the 5th divided by y squared, use your exponent rules, gives me y to the 3rd. 8 divided by 2 is 4. X cubed divided by x squared is x. And then the y squares cancel out. That leaves me with 2x squared y squared times y cubed plus 4x as my answer. It looks complicated, but that's right. All right, those are the GCF problems. If you need more practice, there are 10 more on that same page. Now we're going to look at the difference of perfect squares. Just like the last page, there's factoring example at the top. The things you need to make sure that you have before you can factor by difference of squares. You have to have a binomial, which is 2 terms. You have to have a minus sign in between the 2 terms, which it appears I have for each of these. If there's a plus sign, you cannot factor it. You also have to be able to take the square root of each term. So looking at number 1, I start by taking the square root of x squared. That gives me x. And the square root of 16 is 4. Once I found those square roots, I write 2 sets of parentheses. Each gets an x, each gets a 4, one gets a plus, one gets a minus. And that is your fully factored form. That's it. For number 2, I have a minus sign and I have 2 terms. So I need to see if I can take the square root of 25x squared, which I can, that's 5x, and the square root of 49, which is 7. All right, now I can take that 5x and the 7 and write my factored form. 5x plus 7, 5x minus 7. All right, x squared minus 100. 2 terms, there's a minus sign. The square root of x squared is x. The square root of 100 is 10. So if I can take this x and the 10 into my 2 factors, each parenthesis gets an x, each gets a 10, one gets a plus, one gets a minus. Now let's check our work on this one. I'm going to distribute x times x to give me x squared. X times 10 is plus 10x minus 10x minus 100. That's a good thing because the 10x's cancel off, and you're left with x squared minus 100, which is what we started with right here. So you know you have the right answer. All right, to finish up the difference of squares. 81a squared minus 4b squared. I have 2 terms, I have subtraction. I can take the square root of 81a squared, that's 9a, and I can take the square root of 4b squared, which is 2b. So I'm going to use the 9a and the 2b in my factoring pattern. I'll have 9a minus 2b and 9a plus 2b. That's fully factored, but if you wanted to check, you could use the distributive method. Now the next 2 types of factoring we're going to do are really the same kind of factoring. I just split them up into 2 separate pages. We're going to do trinomials. A trinomial has 3 terms. Okay. There are 2 examples right above up here. I'm going to skip down to the practice. We're going to start with trinomials where the leading coefficient, that a, equals 1. That means there's a 1 in front of the x squared. When I factor these, I'm going to use split the middle. I'm going to multiply 1 times 10, and I need to find 2 numbers that multiply to 10 and add to 7. Well, that seems to be 5 and 2. When I split the middle, I bring down the first term, x squared. I bring down the last term of 10, and I split the middle with the 5x and the 2x. Now, in order to factor, I go ahead and I'm going to group the first 2 terms together and the last 2 terms together. When I pull a GCF out of the left, I have an x, and dividing that out, I get x plus 5. The GCF for the second group has to be positive because there's a plus sign, and it's going to be positive 2. So when I divide out 2, I'm left with x plus 5. Now we were happy every time this happened because I have x plus 5 in both sets of parentheses, which means that I can go ahead and write my factored form as x plus 2 times x plus 5. As with every problem we've done on here, if you want to check your work, you can go ahead and distribute. Now the next problem, 1x squared plus 8x plus 15. I'm going to multiply the 1 times 15, which is 15. I need two numbers that multiply to 15 and add to 8. Those numbers are 5 and 3. I'm going to now split the middle with x squared plus 5x plus 3x plus 15. Once I have 4 terms, I use that method called grouping, where I put the first 2 and the last 2 terms in groups together. This allows me to look for individual GCFs. The GCF between x squared and 5x is x. I divide that out of both terms, and I'm left with x plus 5. Now, because the third term here is positive, my GCF is positive. The GCF between 3x and 15 is 3. So I pull out a 3 and I'm left with x plus 5. But just like the last problem, that's a good thing because I want these to be the same, so I can write my factored form as x plus 3 times x plus 5. All right, there are more split the middle practice on this page with trinomials for a equals 1 with split the middle. We're going to go on to the next couple problems I'm going to do for you, which is split the middle, but the first term is not 1. All right, there is an example at the top of the page up here that you can look at. I'm going to jump down to the examples 1 and 2, all right, with the practice. Now this is again split the middle, but the difference is there's not 1 this time in the front, there's another term. So we're going to always start by multiplying the first number and the last number. 3 times negative 7 is negative 21. I need two numbers that multiply to negative 21 and add to 20. These end up being 21 and negative 1. 21 times negative 1 is negative 21, and 21 minus 1 is 20, which is exactly what I want. So I can split this up as 3x squared, that's the first term coming down, minus 7 is the last term, and I split the middle as plus 21x minus 1x, and then the minus 7. Going ahead to group now, I need to find a GCF for each pair of terms. Between 3x squared and 21x, that GCF ends up being 3x. So when I divide 3x out of both terms, I'm left with x plus 7. Now in the next set of parentheses, my term starts off being negative, so my GCF is going to be negative. The only thing that these two terms have in common is negative 1, so that's my GCF. When I divide negative 1 by negative 1, I'm left with positive 1x. Negative 7 divided by negative 1 leaves me positive 7. The good thing here is that I'm left with x plus 7 and x plus 7. So your final factored form is 3x minus 1 times x plus 7. All right, last problem on this video I'm going to go over with you. 7x squared minus 34x minus 5. I'm going to multiply the 7 and the negative 5 to get negative 35. So I need to find two numbers that multiply to negative 35 and add to negative 34. This is actually going to be negative 35 and positive 1. Once I split the middle here, I'm going to have 7x squared minus 35x plus 1x minus 5. Now I'm going to go ahead and group. Right? When I group, I now look for a GCF. 7x squared minus 35x has a GCF of 7x. I'm going to divide both terms by 7x, and I'm left with x minus 5. Now in this second set of parentheses, my first term is positive, so my GCF is positive. The only thing these have in common are a 1, so that's my GCF. When I divide by 1, I'm left with 1x minus 5. All right, and there we have x minus 5 the same in both sets. So your final factored form is 7x plus 1 times x minus 5. All right, so that's the last practice video for the factoring unit. If you have other factoring questions, you need to come in and see your instructor during office hours or try lots of practice with their keys posted to Canvas. This is a really important skill that you're going to need in the next unit and beyond in geometry and algebra 2. So it's really important that you master this skill.